This course consists of the modules listed on this page. Selecting a module will navigate directly to that module, and you can always return to this page by selecting Course Outline in the left menu panel. The overall RSA Security Access System is very flexible and extensible and provides a number of options for constructing and arranging an infrastructure. This system diagram generally depicts the components that can be included in a system. Not all are required for every type of implementation. We'll break down this high-level view to give you more detail about each component, what other components each can connect to, and what functions result from those connections. So let's take this diagram from the top. Authenticators are an important part of the RSA Security Access System. Traditional RSA Security tokens, the RSA Security Authenticate app, and FIDO-compliant RSA Security Key, as well as other authenticator methods, are described in the Introduction to the RSA Security Access Solution on-demand learning course. If you have not already viewed that course, you can find a link to the RSA Security Access training page under this player's resources list. Next, we'll consider the placement or location of system components. RSA Security Access is designed as a hybrid solution where components are both in the cloud and on a customer's premise. The RSA Security Access Cloud Authentication Service is cloud-based and is provisioned and managed by RSA. All other components reside and are managed on-premise. But on-premise does not necessarily mean on a customer's physical site or network. Components can be installed and connected to a customer's virtual private cloud, such as through Microsoft Azure or Amazon Web Services. For the purposes of description and discussion, we'll consider this to be on-premise as well. The only exception is any component that is a physical hardware appliance, which obviously would need to be installed on the physical site. The Cloud Authentication Service manages access-protected applications that are presented to users in the application portal, access policies and rules, and authentication methods that apply to different assurance levels. It also initiates the Approve Authentication transactions and validates RSA Security Authenticate token codes as well as FIDO authentication. Cloud Authentication Service functions are managed through the Cloud Administration Console, and user information is retrieved through the on-premise identity router, which in turn connects to an LDAP or Active Directory identity source. User information used by the Cloud Authentication Service includes user IDs and attribute information. Sensitive password information is validated through the identity router, but is not duplicated or stored by the Cloud Authentication Service and remains secured in the directory server. Some authentication agents can be installed or configured to communicate directly to the Cloud Authentication Service to take advantage of RSA Security Authenticate token codes or FIDO authentication through the agent. In addition, the Cloud Authentication Service can also accept authentication requests from third-party applications, typically using the SAML protocol. In this case, the Cloud Authentication Service acts as the identity provider for the SAML application. Because the Cloud Authentication Service is managed by RSA, the only on-premise concern is making sure appropriate ports are opened and the service URL is whitelisted to allow traffic to the Cloud Authentication Service. The Identity Router component connects to the Cloud Authentication Service and is also managed through the Cloud Administration Console. A separate setup console manages the identity router configuration, such as for network IP address and DNS, and provides access to logs and diagnostics. And as we mentioned, the identity router connects to a directory server for user information. The identity router hosts the user application portal that makes web and cloud applications available to selected users based on access policies and rules. It also provides a Radius server so that Radius clients in an organization can authenticate using RSAsecID Authenticate or FIDO functions. And a function known as Integrated Windows Authentication allows users to connect to the application portal by automatically using their Windows domain credentials rather than requiring a user to type in their credentials. Multiple identity routers can be installed and configured in clusters to provide an organization high availability and to assist in disaster recovery. Another major component of the RSAsecID access system is the RSA Authentication Manager Token Server, also termed Authentication Server or simply Authentication Manager Server. The server functions to manage user accounts, RSAsecID token records, authentication policies, agent records, and other objects and functions within the system. Most of this information is stored in its internal database, but Authentication Manager can connect to and retrieve user information from an external directory server as well. Management is achieved through web-based administration consoles. Authentication agents, that we'll describe more in a moment, send user authentication passcodes from traditional RSAsecID tokens to the server for validation. The Authentication Manager server also provides a Radius server, and multiple servers can be connected together to provide high availability and disaster recovery functions. The initial server in a deployment is always established as the primary server. Additional servers are designated replica servers and contain replicated information from the primary. Replica servers can also have individual connections to directory servers. One more RSA Authentication Manager component that is part of the overall system is the Web Tier server. The Web Tier is installed in the network DMZ so that users from outside the network can access it safely and isolate it from the token server. It supports an end-user self-service console where users can request and manage RSAsecID authenticators, as well as reset pins, activate tokens, and other self-service functions as configured and allowed by self-service policies. It supports secure CT-KIP activation of RSAsecID software tokens and is used in conjunction with RSA Authentication Manager risk-based authentication. Authentication agents are important for protecting access and authenticating users logging into network endpoints and other access points. Traditional agents send user login credentials with RSAsecID passcodes to the RSA Authentication Manager server for validation. Traditional agents send authentication requests to the server using the UDP protocol, so are generally termed UDP agents. The server response of access allowed or denied is returned using a TCP protocol so that communication to a specific agent is assured. In the case where there are multiple authentication servers, agents can determine which server has the best response and will send authentication requests to that server. Some agents, particularly the newer agent releases, connect to the authentication server using a secure REST connection. These agents are generally termed REST protocol agents and depending on the specific agent, may be configured for either UDP or REST connections, but not both at the same time. And a third type of agent can connect directly to the Cloud Authentication Service to process and validate RSA SecID Authenticate token codes, approve authentication, or FIDO authentication. This connection also uses the REST protocol. Connecting RSA Authentication Manager with the Identity Router or Cloud Authentication Service adds additional authentication options. Using the Cloud Administration Console to configure a connection from the Identity Router side effectively makes the Identity Router function as an authentication agent to RSA Authentication Manager. This allows users to use RSA SecID authenticators as additional authentication for accessing applications through the application portal, where the application has an access policy requiring RSA SecID. The user's passcode is passed to RSA Authentication Manager for validation. And using the RSA Authentication Manager Security Console to configure a connection between Authentication Manager and the Cloud Authentication Service allows users to take advantage of the RSA SecID Authenticate mobile app and log in through traditional authentication agents. Existing agents can be used without modification or other administrative action at the agent. This makes this option ideal for transitioning users from traditional tokens to multi-factor mobile devices if desired. In this connection, the MFA token code or approve authentication is passed to and validated by the Cloud Authentication Service. At this point, we've covered the basics of the RSA SecID access components that you might find in an overall system and how they interact. In the next module, we'll describe the platforms that support these components and fill in some additional details. The RSA Authentication Manager servers can be installed as a virtual appliance on VMware or Hyper-V platforms, or in an organization's Amazon Web Services or Azure Virtual Private Cloud. Servers are also available as pre-installed hardware appliances. Primary and replica servers can be on the same platform or can be installed across mixed platforms. The primary server provides full read and write access to the internal database for administration, for example, adding new users, provisioning RSA SecID tokens, or other management tasks. Replica servers are read-only for these administration operations. Replica servers receive database updates from the primary server and always respond to authentication requests from authentication agents. If a primary server fails and cannot be recovered, a replica server can be promoted to function as a new primary server. For specific information on the most recent platform system requirements, always refer to the product pages of RSA Link. As versions of RSA Authentication Manager are released, some requirements may change or additional platform options may become available. Identity routers can be installed on-premise as VMware or Hyper-V virtual appliances, or in an Amazon Web Services virtual private cloud. For physical on-premise deployments, an identity router is typically configured with two interface ports, one for management that is used for internal communications and control, and a portal interface that is the connection point for the application portal, where end users will access configured web and cloud applications. Each port is assigned an IP address and a DNS record. If the identity router is deployed in an Amazon cloud, only one interface is available and is configured as the management port. Multiple identity routers can be installed and configured as a cluster to provide higher availability, load balancing, and redundancy. Clustered identity routers do require a third-party load balancer to distribute traffic between them. Quorum mode is invoked if more than half of the identity routers in a cluster are out of service. In our example of 3 identity routers, if one becomes disabled, the cluster continues to function normally. But if 2 routers are out of service, more than one half, the cluster goes into read-only mode until the identity routers can be restored or replaced. RSA has authentication agents for several platforms. In Unix and Linux, the RSA authentication agent for PAM provides protection for users attempting to access services such as remote login, substitute user or SU, telnet, and similar services. For RSA authentication agents for web, the agent can be configured to protect an entire website or specific pages or resources within that site. Microsoft IIS and Apache web servers are supported platforms for the web agent. For Windows and Mac workstations, agents can protect login to the workstation, can offer offline access, and can authenticate users with a variety of methods. Specific functions and options vary with the operating system version, the agent used, and whether RSA Authentication Manager or the Cloud Authentication Service is being used. We've already mentioned the UDP or REST communication protocols. These options also depend on specific versions of the agent and an organization's preference for authentication, either through the Cloud Authentication Service or through RSA Authentication Manager or both. In addition to what RSA produces, agent code is built into hundreds of technology partner products, many of which need minimal configuration to send multi-factor authentications to the RSA server or service. And our advice, as always, is to refer to RSA Link for specific platforms, system requirements, and implementation guides to help you configure any RSA-ready partner products. You can find links to the partner implementation guides and RSA Secure ID Access product page on RSA Link under the Resources link at the top of this player. RSA Secure ID Access has several pathways for processing user authentications. Listed here are 5 general authentication scenarios. Click on any one to view the authentication flow, or click the Next button to continue to the next module. The application portal is a web interface for end users hosted by the identity router. Applications and the policies to access the applications are configured in the Cloud Authentication Service. The portal is available to users both on an organization's private network as well as from the public Internet. This provides a single location for users to access their applications. Once a user logs into the portal, they can select any available applications. If additional authentication is needed to access a particular application, the user is sent an approve notification, prompted for an RSA Secure ID passcode, or any other authentication method configured for the application. If a user does not close their browser, they have access to multiple applications of similar or lesser authentication level without the need to sign in again or resubmit additional authentication, thus providing single sign-on to those applications. The My Page portal is hosted by the Cloud Authentication Service and provides self-service capability to users registering their RSA Security Authenticate app or FIDO device. Users navigate to My Page and can register their device by scanning a QR code on screen or by entering a registration code. Upon successful registration, My Page initiates a test to make sure the user's device is functioning with the system. On the My Page screen, users are also presented with a link to view an overview of the registration process and to open additional help documentation as needed. Click the bar at the bottom of the screen to launch a brief demonstration of the My Page portal. This same demonstration is also presented to users on My Page so that they can see an overview of the device registration process. The RSA Authentication Manager Self-Service Console is hosted through the Web Tier component of RSA Authentication Manager. It is positioned to give users public-facing access in an organization's network DMZ. The Self-Service Console allows users to request, activate, and manage their RSA SecID tokens and other authentication methods. Exactly what users have access to the console and what operations they can perform are configurable by an administrator. One section of the console displays the user's profile information and allows editing if so permitted in the configuration. Another section displays the user's authenticator assignments and links for self-service operations. The Cloud Administration Console connects to the Cloud Authentication Service and gives administrators access to system objects and configurations involved with authentication and access through the application portal. Although there is a connection to the identity router, management of most objects involves information stored in the Cloud Authentication Service tenant. Among the management functions accessed through the Administration Console are listing user devices in known browsers, configuration and management of access policies and rules, configuring applications for the application portal, managing authentication methods for application access, and adding and maintaining Radius clients. An event monitor incorporated into the console displays recent events for users such as authentication activity and application access, and can be useful for troubleshooting end-user problems. RSA Link is RSA's community and support website. If you have not already visited and registered on RSA Link, please do so at your next opportunity. RSA Link offers the latest product information, product and documentation downloads, as well as support information, tips, discussions, and other useful information from the RSA SecID Access community at large. Before you leave this course, kindly take a few minutes to tell us what you think about the content, if it has been useful to you, and give us any suggestions for future revisions. Click the Launch Survey button or scan the QR code to open the course survey. If you do this now and bookmark the survey, you won't forget it later. This course has given you a broad overview of RSA SecID Access, its components, and general capabilities. If you are an administrator or help desk specialist and would like more in-depth training with hands-on experience in component operations, check out the RSA SecID Access 1 Administration Training course. This 4-day course is offered as instructor-led training or recorded on-demand classroom. Both options offer similar instructor lecture and hands-on lab content in our virtual lab environment. For more technical training that includes installation and configuration of the RSA SecID Access components, RSA University also offers an RSA SecID Access 2 Infrastructure Administration and Tuning course, also 4 days of instructor-led training, as well as available in an on-demand classroom format. Information on other aspects of the RSA SecID Access product can be found in other training offerings from RSA University. All of RSA University's education offerings are available on RSA Link. Select RSA SecID Access for a listing. If you have other RSA products in your organization or are considering adding other products, view the video presentation referenced on this page to learn more about how all of RSA's product family can be integrated and work together to contribute to an overall security management program.